Hey there, welcome to the AP Stats Quideo number 3. We're going to get started by answering the basic question. The basic question is talking about the most popular car colors in North America in 2000, and it gives us a chart here with each color, silver, white, black, dark green, dark blue, and medium red, and the probability that a car in 2000 would be one of those colors. The first part of this question, part A, asks what is the probability that the vehicle you choose has any other color than the 6 listed? The first step in answering this question is by finding the total probability of a car being one of the most popular 6 colors. So to find that, you add up each of the individual probabilities for each of the colors, 0.176 plus 0.172, and so on, and you get 0.705 as your answer. And that, again, is the probability that a car in 2000 would be one of the most popular 6 colors. Now, that's not what the question asked. The question asked, what is the probability that a car in 2000 would not be one of those colors? And so the probability of the complement of A is not one of the 6 colors, and you do that by taking the total probability, which is 1, minus the probability of the most popular cars, and that gives you 0.295 or 29.5%. The second part of the basic question, part B, asks what is the probability that a randomly chosen vehicle is either silver or white? You answer this question by finding the probability of the union of A and B, which is the same as the probability of A plus the probability of B. So the probability of A, or the probability of a silver car, is 0.176. The probability of B, or the probability of a white car, is 0.172. So you just add those together as shown in the equation up here. 0.176 plus 0.172 equals 0.348 or 34.8%. Part C of this problem says choose 2 vehicles at random. What is the probability that both are silver or both are white? So this problem is very similar to what we just did in problem B. So you'd start out with the probability of finding silver twice, which is just the probability of A squared. So when you do that, you get 0.176 squared equals 0.031. And then you do the same thing for white cars. The probability of a white car twice, or the probability of B squared, is 0.172 squared, which equals 0.0296. So the question is asking what is the probability of, when selecting 2 cars, either both are silver or both are white, which is very similar to the problem we just did in B, where you're going to add them. So you're going to take the probability of A squared plus, because it's or, the probability of B squared, which gives you 0.031 plus 0.0296, which equals 0.0606 or 6.06%. All right, now we're going to move on to the advanced question of Quideo number 2. The advanced question gives us a table with the age groups of children and their respective median 6-minute walking distances. So the distance in meters that they're able to walk in 6 minutes at these ages. For this problem, we're going to mainly be working with their representative age groups, the midpoint of the age groups, and the median 6-minute walking distances. This is our response variable, this as our explanatory variable. So question A asks us to determine the least squares regression line. The least squares regression line is a line that shows how strong the relationship between the age groups and the walking distances are. And we find this in our calculators by clicking Stats Edit and entering in all of the representative ages in our list 1 and all of the median 6-minute walking distances in our list 2. We then click Stats, Calc, and go all the way down to 8, the linear regression line equation. We click Enter, and it gives us the equation y equals a plus bx. It also gives us our a value and our b value. Our a value is 492.7977, and our b value is 14.7633. Now I've written this out right here just so that we can examine it together. So the final equation is y hat equals 492.7977 plus 14.7633x. And that is our least squares regression line equation. It then asks us to interpret the meaning of its slope. So the slope in this equation is our b value, or 14.7633. And the meaning of the slope in this equation is pretty much that each year the children grow older, they're able to walk 14.7 more meters in 6 minutes. So each year they grow older, they're able to walk this much farther in the 6-minute walking period. Part B asks us to compute the residuals and construct a residual plot. For this, we're going to go back to our calculator, go back to Stats Edit to get to our lists. Now, I already have the residuals here, but I am going to show you how to do it. So we go up to L3, we click Second List, and see Resid here, number 7, click 7, enter, and it will give us all of these data points. Now, in order to graph it, we go to Second Stat Plot, enter. We again make sure that's turned on. We make sure we have our scatter plot chosen. And then the X list is still our L1 variables, but this time our Y list is our L3, or our residuals that we just calculated. So once you're there, you can click Zoom 9, and there it gives you your residual plot. So it then asks us to determine, or pretty much to interpret this graph. So there's not a definite trend between the residuals and the representative age. So there's no curved relationship or linear relationships. It's scattered all over the place, which is good. That means there's no unusual features. Because there's no unusual features, it shows that the ages and median walking distance have a very strong linear relationship. So if this wasn't scattered and it did have a linear trend or a curved look to it, that would mean that the representative ages and the median walking distances weren't very strongly correlated, or they didn't have a very strong relationship. But because it is scattered like this, it shows that the older you get, the farther you'll be able to walk in 6-minute increments.